All right, now we're good. Sorry, I didn't realize you couldn't hear me. So let's rewind that. So essentially, we're talking about confined spaces. We've got regulation 1910.146. There's also another regulation that revolves around crawl spaces and attics. But essentially, what we're trying to do and understand is what's on the screen. We're trying to confirm whether or not that space can be occupied by a person. So when we talk about confined spaces, 65% of the fatalities are caused by air quality problems. Most of the times, the air is not even monitored. So if you're not currently doing your pre-use entry inspections and do your continuous monitoring, that's an issue, especially if you're going into something in a confined space. And we're going to define a confined space, so don't worry. And then 60% of the workers who die in confined spaces are would-be rescuers, meaning it's not necessarily that firefighter that dies that's trying to rescue. It's if Jason and I are working in a manhole and Jason's down and I see Jason drop and I try to go rescue him. That's what we're saying who the rescuer is. That would-be rescuer is me, the other employee, trying to save Jason. And there are, unfortunately, countless scenarios where that has happened. And a lot of times, like I say, what I was discussing right before we got changed the feed was there's a great video with this Illinois State Trooper coming up to an accident with ammonia haulers. And you can see the difference between the way he reacts and eventually you see the firefighters come up. The state trooper sees a person laying in the middle of the road. He grabs his first aid kit and he just runs right to him. And he misidentifies the ammonia in the air as a fire. And it is not a very windy day, so you can just kind of see it suspended in the air. I don't know how he didn't smell it right when he got out. There's probably 10 million parts out in that air. I mean, it is everywhere. So he runs up, and then eventually he realizes, oh shit, I'm having problems. So you see him kneel down. He's like, hey buddy, come on. And then all of a sudden you see the cloud move. And it starts going over, and he realizes, oh shit, I'm in a bad spot. And he tries to get up and go. Well, then you can't see him. There's literally so much ammonia, you can't see him. And then it blows apart. And where do you see him? Laying right next to the very person he was trying to save. So that's what I'm talking about. And then when you see the fire department come up, you can see they come from the other direction. They get out, they're grabbing their equipment, they're putting stuff on. They don't just run right into, essentially a fire. They understand what the hazards are before they make those reactions. And then 29% of workers who die in confined spaces are supervisors, foremen, and managers. So here's just some more stats. I'm not going to go over all these, but essentially if you're wanting, this is a great link. If you have this presentation, you want to do your own presentation at your own shops, there's a link here that OHS Online did with a lot of great information, essentially trying to reduce the amount of confined space fatalities. And they literally go through all the different confined spaces. As you can see, hydrogen sulfide, H2S, which is going to be very, very common for your guys' application, is the #1 killer in confined spaces. So, and here's just some more statistics. And this is looking at specific to fatalities. 0% had a rescue plan. So nobody even had a rescue plan in the fatalities. So just some really eye-opening stuff. And I guess the point of today in showing you all this is to improve upon some of these things so you have these items, so you are prepared. If there is a confined space injury or fatality, obviously we're trying to prevent both, you guys are prepared to respond to those different things. And then really out of the 100 deaths that were investigated, the main reason that workers were entered the confined space were just to perform the regular job duties. So it wasn't even, they obviously went down there all the time. So they might have been in that confined space 100 times. And they hit this lottery, I guess, for death because that one time was the one time that there was an atmospheric issue or some other issue that caused them to have that fatality. So, how do we define a confined space? This is a confined space, not a permit-required confined space. One that meets all three of the following conditions for a confined space. It's large enough and so configured that an employee can bodily enter it and assign to perform work. and has limited means of entry or exit. So you can have a room that potentially is a confined space. Say you have a room exactly like we're in. You got one entrance there and one exit there. But say between the entrance and exits, there's a bunch of pipes you got to climb over. Anybody think that's a confined space? It says limited means of entry and exit because you got to climb over pipes. And this is going back to what we were talking right before this. What happens if I break my leg on the other side of that pipe? How the heck am I going to get over? So that is literally, it can be a room like that, and it can be a permit required confined space. And you are the determiners of that, whether or not it's a confined space or a permit required confined space. And it is also not designed for continuous occupancy. So think about if you've got a, a hopper or something like that. Maybe it's a silo that you're in, that you're cleaning it or you're doing inspecting. That silo is not designed for continuous occupancy. So that, now you've got a confined space. It meets all three of those. Underground vaults. You guys probably have underground vaults. Tanks, storage bins, manholes, pits, silos, pipelines. Now, here's the biggest miss, I think, on a lot of people. A lot of people want to just name stuff confined spaces. They don't want to name things permit required confined spaces. Because if you name something a permit required confined space, now there's a lot more regulations that involve with that. And I've seen people deregulate confined spaces, and I'm like, are you sure about that? Because this is what you got to do for permit required confined space. Is a space that has one or more of the following. Just only has to have one of them. Contains or could contain a hazardous or a potentially hazardous atmosphere. So you guys have a lot of those. Contains a material that has a potential for engulfing the entrant. Think about, this is grain bins, or maybe you've got a storage container where potentially you can dump in your chlorine, or maybe it's a liquid or something like that. Maybe you're in there cleaning it, and there's potential for, if someone is in there, say somebody didn't do their lockout tagout, and they flipped a switch on and dumped all that stuff in on somebody. That's what they're talking about there. Has or could have inwardly converging walls that could trap or asphyxiate. So if you've got the bottom of a tank that's got angled walls, that's what they're talking about there. Contains or could contain serious physical hazards such as unguarded machinery or live wires. Maybe I got to go into a crawl space and there's freaking wires everywhere, water sitting in there, etc. That's what they're talking about there. Here's the last one that gets absolutely everybody, and you can't really defend this. Has or could have any other recognized safety hazard. So what if it's dark? That's a safety hazard you can't see. What if there's mice or rats? Because you guys underground. What if there's rats? That's a safety hazard to me because I don't want to be around rats. So that's where you get on a permit required, and where people try to say stuff is a confined space and not a permit required confined space. That last sentence is where you struggle trying to defend yourself when you try to just say it's a confined space and not a permit required confined space. So, confined space workers. Now we're specifically talking about the workers. This is a great example for you guys out on your city streets, potentially, if you're, or at a pump station or something like that. You've got the entrant, you've got an attendant, you've got an entry supervisor, and an emergency rescuer. You see how there's there's 3 people for one person going in? How many people want to admit here that normally a lot of times they only have one person for one person going in? So they only have a 1-to-1 ratio instead of a 3-to-1. Because I'm not going to call you out, embarrass you, but I know it happens because, of course, we're all busy. People don't show up for work. You've got you only got 2 people available. Yeah, I understand it happens. But if you want to do it right, you got to have those 3 people. So what's the entry supervisor do? Means a person, such as an employer, crewman, foreman, crew chief, is responsible for determining if any acceptable conditions are present at a permit space where entry is planned. So essentially they oversee everything. That's what the entry supervisor does. Authorized entrant essentially means a person, like the picture shows, it's climbing in. They're the person that's going to go in and do the work. And then you got an attendant. It's the individual. I think you were talking about it, Rich, about the attendant, making sure they don't have their phone, they're not distracted, that they're communicating with the person that's in the confined space, giving those direct read readouts. So you can see what he's doing there with his gas monitor. essentially monitoring the air and the individual outside the permitted space. So, and of course, we did not talk about, yeah, and then of course there's emergency rescuer. So that person is the person that if the entrant becomes asphyxiated, has a problem, breaks a leg, has a heart attack, that's the person that's going in to rescue that individual. So 3 basic atmospheric gas hazards. Of course, oxygen. Are you deficient or are you enriched? Because both things can cause issues. Of course, being deficient would be lower than 19.5%. If I can show a gas monitor right now in this room, I know it has 20.9% oxygen because we're all standing and upright. So if it goes below 19.5%, all of us have struggled. We have problems breathing. And all, of course, would be affected a little bit different ways. But that's all, 1.4% is all we're talking about, is the oxygen that our body starts having issues with. Of course, enriched can cause issues as well from flammability standpoints, explosions, etc. Human senses cannot detect oxygen deficiency or enrichment. So like we don't know, I'm breathing this here, it feels like it doesn't have enough oxygen. We don't know that. Our body will eventually start, because you're trying to get more air and your body's not getting enough air, that's when you know, but you can't actually sense if something. Of course you got your flammable gases and vapors. H2S can explode. There is a explosive limit of a lot of different contaminants. All of them are going to be all of them are going to be different levels. And then, of course, there's toxic contaminants. So, essentially, hazardous atmospheres are any atmosphere that can become oxygen deficient or oxygen enriched. It's essentially what we're looking at there. So, toxic atmospheres can come from the environment. Maybe it's microbial. You're breaking down and those bacteria is releasing those gases. Of course, that is an application for you guys that you could potentially have. Products or chemicals stored in a confined space. So there's so you can see like this guy welding in the pipe. I assume you guys probably, especially here in Peoria, you probably have you're talking about a 60-inch pipe. You probably have a lot of pipes like that. So there's a specific example, I think it was out in like Utah. Guys were in this pipe, there was like 6 of them. It was much bigger than what's there, but they brought a bunch of MEK down this pipe. I mean, it was like 1,500 feet. They're cleaning their paint guns, they're spraying something. They had a ton of MEK. Methyl ethyl ketone, it's very, very flammable. They had a fire because they had all this crap stored in. I don't know how, I don't remember exactly the details, but that's what I'm talking about. They brought the hazard into that confined space and they had it all sitting right there. They literally had to go like another 1,000 feet down this pipe trying to get away from the smoke. It was so black the firefighters couldn't even get to them. So that's things that you have to think about when you're doing things in pipes and underground, etc. Make sure you understand what potential hazards there are. Work being performed in the confined space, of course, the welding creates potential gases, and then areas adjacent to that confined space. We had Tom, our gas detection specialist, had an example of a construction crew in a pipe like this underground. Their monitors kept going off, and they could not figure out why their monitors were going off. But like a half a mile down the road, there was a big construction project, and it was all the exhaust from all their equipment and stuff they had running was right by their intake. So they're literally getting all that gas because it was running all day long, and that's what's making their monitor. They thought something was wrong with the monitors. But he's like, no, the monitors work. The monitor's telling you need to get the hell out of that. So it's not necessarily your work. It could be somebody next to you creating that gas that comes into your area. There we go. Of course, here's your different types and styles. You got the boilers. You got vaults, which I'm assuming you guys probably have some vaults. Manholes is definitely obviously something you guys are going to do. Trenches. I don't know if you guys do any trenches, but you're below 5 feet in a trench, you got to have a gas monitor. Pipes, we already talked about, and then tanks. So all different types of applications where potentially you could have a hazardous atmosphere. So what is defined as entry? Essentially any action resulting in any part of the body breaking that plane. So that guy right there got balls of steel because he's going down a manhole with nothing. So obviously you can see that's like New York City or wherever it is. So if you break the plane of that confined space, that's technically considered injury. So initial monitoring, you can see what he's doing there. Initial monitoring, atmospheric monitoring should be conducted continuously during all phases of that permit required space. You got to do it all the time. If any exposure or action level is exceeded at any time during the injury, everybody must evacuate. So Jason was talking about, hey, we had a situation where essentially the monitor went off, everybody got out great. It's exactly what you're supposed to do. Again, your personal monitors are ring and run devices. It rings, you run. You don't sit and question and try to figure out what's going on. You get the heck out. So when we talk about atmospheric testing, the main thing is with gas monitors. I get the calls all day, every day. My monitor's not working. Well, when's the last time you calibrated it? Calibrated it? Yeah. You got your gas monitor. It's like a computer. It doesn't, it works right out of the box, but eventually the sensors become desensitized depending on how you're using it and what you're using it. O2 is always the first one to go out, but that needs to be calibrated to make sure every time you're using it that it works. It also needs to have the periodic testing. That's what the bump testing is. So if you have like a docking station where you put your monitor in, you close the docking station, I'll show you one if you don't know what that is. There are manual processes to calibrate gas monitors, but I quite regularly get calls and emails for gas monitors that people just don't know. And if you don't know, that's fine. We'll come and help you understand how to use your monitors and how to use your cal gas and different things like that. But you got to be able to calibrate specific to Honeywell. If you have Honeywell BW Technologies monitors or race systems, typically on every gas monitor it's going to be 180 days to calibrate, and you're bumping every day. Right? So, and then here's just the, if you really want the specifics on how to do it, I'm not going to go through all this just from a time perspective, but this is literally what you need to do for your atmospheric testing, your evaluation, your verification, your duration of the testing. So you see a lot of people, they put the hose down and they just literally, you've got 30 feet down, they just kind of go down really fast and pull it back up. Well, the problem is the more hose you have on that direct read monitor, the longer it takes that gas to get back to the monitor. So if you're going too fast, the monitor can't even respond because you're moving it too fast. So there are very, very specific instructions on how to do your periodic testing and your pre-entry testing on how gases are stratified. I have a thing here in a second. We'll show you how atmospheres can be stratified, and that's why we do it. Depending on how many feet you have and how wide the confined space is, there are very specific instructions on how you do that monitoring. And there's a very specific test for order of testing as well. So here's what I'm talking about. You can see like on the specific example, methane is lighter than air. So it's going to be right, when you pop open that manhole, all the methane's right there at the top. Carbon monoxide weighs the same as air, and then you've got hydrogen sulfide is right at the bottom because it's heavier than air. So that's what we're talking about when you're pulling that monitor. You're going at a pace where the further you get away, the longer it needs to be down there so we can get that air back to the monitor side. So here's on the right, 21% down to 6%. That's essentially what happens to the human body. So of course, minimum for safety entry is 19.5%. At 16%, you're going to start having impairment in judgment and breathing. At 14%, you're going to be your body's trying to get air in. And then at 6%, it's really going to be difficult to breathe, and you're probably going to be dead in minutes. Now the problem is with things like hydrogen sulfide, I don't know if you guys would ever have this application. I know it's in hog barns, but do you ever get your poop and I'm assuming you guys are doing waste as well, correct? At most of your facilities? Does it ever get crusty and hard on top? No? Yeah? I'm saying yeah? Has anybody ever taken a post and accidentally broke it or stepped into it? I'm assuming there's probably applications where that happens. The problem with doing that is if it's been sitting there for a long time, all that H2S is underneath that lid. And once you break it open, where does it go? Right in your face. The problem is, I think somebody can probably correct me if I'm wrong. It's been 9 months since I've done this training, but I'm pretty sure on H2S, what they call, and we'll talk about it in the respiratory section, but the IDLH, the immediately dangerous to life and health, is 700 ppm on, or actually I think instantaneous death might be at 700 ppm for H2S, which you really think that's 700 parts per million. So if there's a million parts, 700 of them have to be H2S, and it can kill you. So we can go find stories, unfortunately, of farmers, because they had, for whatever reason, and I think it's cattle that have a really hard crust. When you break that crust, there's, unfortunately, instances where immediate death by smelling. And hogs are the same way. You see the father and the son that have died in the manure pits because they break that crust, and all that H2S comes out, and it is just way too much. So be very, 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 very careful when you're around if you get anything with a crust on it, because all that gas is trapped underneath that crust and it can't remove, and your monitor is not going to pick it up because it's underneath the crust. So just keep that in mind when you're doing it, because it's heavier than air too. So that means all that H2S is going to be down at your feet. So if you've got to get down on your feet and you haven't done all your pre-use testing, that's where all the H2S is. So you may be fine when you're standing up, but you find, oh shoot, when I lean down, my monitor's picking all that up. It's telling me I got to get the heck out of here, and that's the issue. So just keep that in mind. Of course, there's a bunch of different types and styles of monitors. There's even newer monitors that we've come out with than what's on the screen. There's Bluetooth connected monitors, etc., etc. There's what you need to know is there's pumped versions, which is what you see at the top, where you can put the hose in, and that's where you're doing your pre-use inspection. And then there's also diffusion monitors, which are at the bottom. Those are the personal monitors. So you can get them to essentially a monitor to do both, but there's also ones that just do the diffusion style. So you got it on your clip. There's also 4 and 5 gas monitors. There's single gas monitors. So if any of your facilities have chlorine, and you have only one area that has chlorine, and that's the only gas you're looking for, then we have a monitor, a single gas monitor that's just for chlorine. We also have fixed gas. Of course, what we're talking about today is portable gas, but we also have fixed gas, which is a different, it's a different type of monitoring. I mean, it's the same thing, it's just, of course, fixed. But there's different types of monitors. So you got single gas, 4 gas, there's pumped units, you can get disposable units, you can get rechargeable units. Essentially the deal is you got to bump and you got to calibrate. That's the main thing on all these monitors. They don't work unless you bump and calibrate. And one thing I see a lot of people doing is taking their, it's a winter time or even the summertime, taking your monitor and putting it up to the exhaust for your bump and calibration. It's a terrible idea because you're going to poison those the sensors. So do not take your monitor to the edge of your exhaust, and that's going to poison those sensors in there. So not a good idea. So pre-testing confined space, again, you can kind of see the graph there just kind of showing, just use the appropriate direct read gas monitor to ensure that the devices are operational, bump, tested, and calibrated, which we've already kind of talked about. So here at the bottom is what I'm talking about specific. It says allow sufficient time for all sensors to react to each sample per level tested. Key response factors are hose length, typically 2 seconds per foot of flow rate, plus on T90 sensors, their response time. For example, 10 foot of hose times 2 seconds equal 20 seconds plus most significant T90 of monitoring sensors. So typically 30 seconds for standard 4-gas monitor. So if you're going to go down that with 10 feet of hose, it's going to take you 30 seconds to get that reading up at your monitor. Or potentially up to 50 seconds. So, of course, monitor and ventilate continuously. Many of the accidents are required from changes. So you may do your pre-entry inspection. You may go down, you got your thing. But all of a sudden, something happens and now your monitor goes off, and you're already down there. You're like, what the heck, I already did. But atmospheres can change. Gases can change. Again, there's a lot of factors that can potentially pick up those changes. So, what is a calibration and bump? Essentially, a bump test is just that function test to make sure it works. The calibration is a quantitative check that actually says, yes, all these sensors are doing exactly what they're supposed to be doing. And there is also a full calibration as well. So that's the different types of, between a bump, a calibration, and a full calibration. So make sure you follow the manufacturing instructions. Zero the instrument in fresh air prior to use. So you don't want to just turn on your monitor and bring it while you're in the space. You want it in fresh air to make sure it's actually reading correctly. There can be a loss of sensitivity in the sensors that require replacement. A lot of our monitors, you can replace the sensors yourself. So there's aging sensors, could be mechanical damage. Could be that you had an exposure to something that you weren't technically prepared for, etc. That could do it as well. So there's a lot of issues. I'm kind of harping on it here, but make sure you're bumping and calibrating, because like I say, I go to a lot of places and people don't bump and calibrate that. So it can't work if you don't maintain your equipment. And that said, bump and calibration is specific to Honeywell. So if you have different monitors, MSA, Industrial Scientific, etc., check your user instruction manuals for what they say. Frequency. Of course, so now the big thing is here on record keeping. So how do you know if that actual monitor went into an alarm? Now that's what a docking station can be used for. Once you put it on the docking station, you can actually hook that docking station up to your computer, and now you can see all the last time it's bumped, calibrated. Obviously the docking station will do it, but if you want to record the information on your computer, that's how you can hook it up to your docking station and get all that information for OSHA logs and different things like that. You can also have the device connected. Sorry, am I standing too close? Sorry. Stand back. You can also just connect the device. There's also Bluetooth capable instruments, etc., that can pair for a lot of lone workers and different things. There's a lot of new technology. So if you haven't seen the technology, you can reach out to us. We can get our gas detection specialist in touch with you, and we can go from there. So there's what essentially a docking station would look like, where you put your monitor in to do that testing. It's the easiest way. Of course, you're looking at a docking station, you're looking at like $2,500, so it's not like it's inexpensive. But that's what a docking station could potentially look like. So other items that need to be checked, performed, and completed before entering that permit required confined space. The big thing is isolation of the space. Now, we don't do lockout tagout. I don't claim to be a lockout tagout expert, but I can tell you there are very many instances in confined space. The biggest one is bumblebee tuna. If you ever want to look it up, look at the bumblebee. It's a terrible story. The guy was in a tank working. Somebody didn't look to make sure, and the tank and the system was not locked out, and they dumped a bunch of tuna in and flipped on the equipment. So that's what I'm talking about. So say if you guys are out working and you've got the electricity shut off to this space because there's water down there and you're down there working, it needs to be locked out. It also, that space needs to be valves. We were talking to Jason. Maybe you're in that tank and you're doing the same thing the bumblebee tuna guy is, but somebody flips on a valve, opens up a valve, and dumps in a bunch of chemical while you're in there working. That's what we're talking about when you're isolating space, making sure you have your lockout tagout. So of course the person that goes into that space has a key. If you're not familiar with lockout tagout, you got a bunch of keys. That person that would go into that space would have a key. So it can't be unlocked because his lock is on it and you can't open it up without his key. That's your check to make sure, unfortunately, somebody doesn't kill you by opening up a valve, driving a truck over it, whatever the case could be. So making sure you isolate and disconnect potentially anything that could make it hazardous while you're in that permit required confined space. The other thing is ventilation. Making sure you got fresh air. There was a picture, and you can kind of see the two guys working there with the blower up top. We don't make blowers. I can refer you to somebody, a manufacturer that makes blowers, but Allegro makes one, a blower. Pelsu makes a blower, or somebody else that makes a blower. But essentially, circulating that fresh air, so if you have that confined space, we're trying, again, this is your engineering control to make sure that space has consistent fresh air. So ventilation practices, of course, just locate the blower where you're not pulling in, nasty air into your space. That ensures that vapors and gases are exhausted from the space and vented to a safe location. So here's your rescue hierarchy. Employers have options on how to comply with this. So you could do a self-rescue, depending on the situation. Obviously, if a person has a heart attack or something, they're not going to be able to do a self-rescue. Non-entry rescue. This is what a non-entry rescue would look like. If this is my confined space, my rescuer is standing right here because he's hooked up to the rescue retrieval device. So a non-entry rescue, and then a last resort would actually be an entry rescue. Say, for whatever reason, the person that went down on this system, when you pop the pin to start cranking them out, say it gets hooked on something. You can't get them out. Okay, now somebody's got to go down and do it. So those are your three rescue options. Self-rescue, non-entry rescue, or as a last resort, and those are the hierarchy that you should do that as. So the key rescue regulations, ensure that affected employees practice making permit required confined space rescues at least once every 12 months. So if you have a permit required confined space and you're not doing rescue training right now, that's an OSHA violation because you got to be doing it. In which they remove dummies, mannequins, or an actual person from the actual permit required confined space. To facilitate non-entry rescue, retrieval systems or other methods must be used whenever an authorized entrant enters confined space, unless the retrieval equipment would increase the overall risk. So, if you're not doing confined space rescues training right now, we need to add that to your document. Okay, so the main thing I see, and I was at another sanitation department in Illinois, and they were sending 8 people or 7 to 8 people down into a confined space. If you're going to have 7 to 8 people in a permit required confined space, you got to have 7 to 8 of these, because you do not disconnect this. So this device right now, make sure so right now this works. I can just wear this, and if I pull, it's a self-retracting lifeline, so it stops. If I fall, this stops me. Now, if the person's going down and they're just going down, going down, going down, going down, going down, and now all of a sudden, say the gases, they get overcome by gas and they're knocked out. What you do on this is there's a pin right here. You pop this pin, that handle pops out, and now I crank them in. You can see it's going to, that's how that works. So, my point is, that company was literally had one of these stations set up and had everybody going down like this. So what happens? Who's the first? Are you going to fight to see who gets to go up first if your monitors go off? So that's my point. If you have 7 people in a confined space, probably that's an extreme hazard. And they were talking about, we'll just, they said they had some device where, we just have this drill that we can speed up somebody faster. I'm like, I don't know about this one, guys. So if you really have work that requires 8 people to be in a confined space, you really need to reconsider that work. So it's very, very important to have those considerations, because you'd have to have, what happens if all 7 of those guys get overcome with gas? How many, you got to have at least 7 more people up top to go rescue each and every person. Plus you're in a manhole. I mean, there's all sorts of problems with what that scenario was. So just make sure this cable from your rescue retrieval system, never comes off your back D-ring. Now, if I need to be raised or lowered into that, we don't raise and lower with this device. We raise and lower with this device. So you're going to have two cables hooked to you. So if you have a manhole that doesn't have a ladder in it, and you need to lower somebody down, or you need to lower a piece of equipment down, you got to have a manhandler. This thing can do up to 475 pounds. And what you would do on your harness, there's multiple ways you could have it, but like on this particular harness, cable goes to the back, the manhandler goes to my front D-ring. So now as I'm going down that, being lowered down into that hole, I've got my rescue retrieval system on my back D-ring. The manhandler goes in the front, and now I'm kind of just being lowered down like this. So that makes sense to everybody? You have this. So now once I get down to the bottom, I could disconnect that and I get rid of that, but I keep that attached, because if I have problems and I radio somebody, hey, my monitor's going off, boom, they can just pull me up. And then you want, of course, you want your back D-ring, because what if happens if I become unconscious? I want it on my back D-ring, I don't want it on my front D-ring. So if I put on my front D-ring, then I'm going to come out like this if I'm unconscious. If I have it on my back D-ring, I'm going to come out like this. And you're trying to get somebody through a manhole, you want them like this, not like this. So keep that in mind on a confined space. The mechanical device shall be available to retrieve personnel from vertical type permit spaces more than 5 feet. So if you got more than 5 feet, you got to have a tripod, or that we call this system a dirt hoist, to potentially get that person out of that space. So you can see the different pictures there of a entry going down. You got your rescuer right there, and then of course this is a horizontal. And this particular device can be, this is why this is better in my opinion than a lot of your tripods, because this can be used for horizontal and vertical applications. So here I'm just going to go briefly over, of course, most of you guys might have the tripods. There's nothing wrong with tripods. You can continue to use tripods. You use these two same pieces of equipment on a tripod. This just has a lot more versatility. It's got the post here. This post can be different lengths. It's got a lot of different bases with it. You can see here some of the bases. I've got that 3-piece portable base on this unit. There's one for a manhole cover. There's an adjustable barrel mount. These are all fixed, flush mount, wall mount, floor mount. So the idea with this system is you can buy one of these in a bunch of different bases for all your different confined spaces. So that way you only have to take this. You don't have to, take a base everywhere. You just put bases everywhere, and you have this one post. So you even have a version that you put on a vehicle hitch. So if you got to come up to a manhole cover, you just put it right on the back of your vehicle hitch. What I'll say on a vehicle hitch though, you got to think about lockout tagout, because what happens if somebody drives off that truck where you're hooked to it? That's the problem. So you gotta put a lockout tagout if you're going to use the vehicle hitch. Of course, there's flush mount and then a different type of barrel mounted sleeve. But this is an extremely versatile piece of equipment in your applications where you have a bunch of different versions. Or if you've got a tripod where it's kind of angled, well, the problem with the tripod is it's great for up and down applications. If you have to go left or right, the tripod doesn't do so hot. Or if you don't have flat surfaces, like this particular device, these don't even have to be the same width and length. And it's got a level, and it's got levels there, so you can literally adjust it even if you have a floor that's not level. We talked about the manhandler. Of course, this is your SRL rescue retrieval device. Again, you only pop this pin when there's a rescue. So you pop this pin, you'll kind of hear it. Oh, sorry. So you pop this pin. Now it's in rescue retrieval mode. To put it back into SRL mode, you just push the handle back in. But you only pop that pin when there's rescue retrieval. Because the problem is, I've been to places where they're like, hey, my rescue retrieval device doesn't work. Well, and the first question I asked, do you have How do you get into your confined spaces? Do you have ladders? Well, no, we raise and lower. Okay, can I see you set up your setup? Nobody will have these. Everybody will have these, and this is how they're raising and lower. This is not designed to raise and lower. You want this thing, when you pop that pin, you want those gears in there to work. It's not designed to raise and lower. Got to have one of these. The other thing I see, this is specific to Honeywell. You can't really see it very well on this setup, but this top pin here, it just hooks over the top like that. So you see that top pin is in. You don't actually put the pin through this. You hang it on the pin like that. So I see a lot of misapplication of this. Everybody tries to get this pin in and put it in through. That's not how this is designed. It's designed to sit on top, and then you just put the pin in. The problem is these two holes are offset, and there's not two offset holes, so then you only put in one pin. Actually, the customer I saw most recently doing that was here in Peoria. That did that. So just FYI, just specific to this setup, this is how you got to do it. These can be repaired. Of course, you can send these back to Miller, and we can repair these. So if you do have a fall, or if it's not working, both this and this can be repaired, just as an FYI. So additional confined space essentials, you can get a rescue ladder. So maybe you have again, something that doesn't have a ladder in it, you can throw down a ladder, or if somebody fell over the side of the building, you can throw down a ladder. Of course, you got different types of carabiners, different anchor straps, or different rope. There's lots of different ways to rescue somebody. So there's got a lot of different types and styles of rescue equipment. We do have specific confined space rescue classes. It's a 2-day class, I believe, where you can go through confined space rescue. I believe we do it in, we can do it on site, so if you guys wanted to set it up, I'm pretty sure we could do it on site, but we also do classes in Pennsylvania and Texas, because we actually have a gym where it has a bunch of faux confined spaces where you actually get to do all this stuff. There's different rescue systems. You can see the quick pick rescue system. We've got a Miller Series 70. You can see kind of with it's kind of got like a Busan chair. The quick pick rescue system is essentially just a pulley system. You got 2 pulleys. You put, of course, a cross arm strap with 1 pulley. The other pulley goes to the person. So you use this pole that's there. It holds open the carabiner. A carabiner like this, of course, attached to that system, but you use the pole, and the pole holds the carabiner open like this pole does, and then what you do is you take that pole, and what you're guiding for is a back D-ring, and then once you hit the back D-ring, when you pull it, pull the pole out, it closes the carabiner, and then you get rid of the pole once you're done with the pole, and then you just use the 2 pulleys. You can either raise or lower that person depending on what the application is. So that's that quick pick rescue system. Miller Series 70 kind of works just a little bit different way. We also have a safe escape system. It's more for, I don't know if you guys would ever have an application for it. I won't go over it because it's a very specific application. Just depends if your facility had something that would fit the application. So does anybody have any questions on gas detection or fall protection for specific to confined space? Because the last about half hour here, we're going to go over respiratory equipment. So, how to make respiratory selection. My first job at Honeywell, I was a respiratory specialist. I would say that respiratory is our most technical product line. I know fall protection seems very technical, but quite regularly see people misapply respiratory protection. And respiratory protection is not like fall protection. If you're up working at 4 feet, you got to have fall protection on. Well, just because you're in a confined space doesn't mean necessarily you have a respiratory issue. Now, there could be. You may be welding, you may be painting, you may be grinding, you may have hazards in the atmosphere that require you to wear respiratory, or maybe there is a potential for hazards in the atmosphere. So that's why respiratory selection, we're going to go literally through respiratory selection and how to make it through this presentation, because like I say, it's very, very, very technical in nature. You can see the guy on the right doing his gas monitor, and he's got a system on. I actually have that system sitting here, and then you can see an employee with an SCBA on. Does anybody have SCBAs or any kind of respiratory equipment at their facilities? No? You guys have any?
We have 10-minute air escapes.
Okay.
We used to have Scott air packs. We decided to get rid of them.
Okay, yeah. I mean, it's very common, and it's probably because I'm assuming the training piece and everything that goes with it. Okay, and I know the system I have over here looks very complex. It's really not very complex, but it's a training thing. It's just like confined space and everything else. You gotta stay on top of it, and people have to know how to use this equipment when shit hits the fan. So that's why a lot of people, of course, they have a different rescue plan. What he's talking about is a escape bottle would be something like this, and we'll talk about this specifically, but this is what he was talking about with an escape bottle. The system over here, this device is specifically called an air cart, and this device sitting here on the floor, which is what the guy on the right's wearing, that's called a pressure demand supplied air system. And then what's on the left is what a firefighter wears, a self-contained breathing apparatus. So all your air is coming from the tank on your back. There are rules and regulations to properly maintain like any piece of life-saving equipment. Granted, you've got a resource like myself that lives locally that can help you assist if you really think, I think for our applications we may have a need to have something like this on site. So don't be afraid because people that have been in safety for years do not understand respiratory protection based on conversations I've had the last 4 years. So how do you make respiratory selection? It's essentially you've got to estimate the exposure of the hazard. So again, you're going to say, how the hell do you estimate potential hazards? Okay, there are third parties out there that can assist you with air monitoring. So essentially, it's kind of like a gas monitor. You can wear an air monitor. You could have somebody. You could do an air monitoring survey here, where employees would wear those air monitors, and they just wear them around as they work. And then the industrial hygienist takes that information back and says, okay, for these applications, this is what we're requiring for you to wear for respiratory protection. I mean, that's literally, it's a certified industrial hygienist, if you're familiar. There's a lot of third parties, even here in Peoria, that can help you assist with that. Because typically when we think about respiratory, we think about acute and chronic. Acute would be something like chlorine or H2S that can kill you like that. You breathe in a couple breaths and boom, you're dead. Where chronic would be something like hexchrome, where you get the metal fever, something like that, or the biggest one is mesothelioma. I don't know if you guys still have any asbestos wrapped around your pipes and different things like that have asbestos. Those would be things that are chronic. Not going to kill you today, but by the time you hit, if you work someplace for 25 years, now you have lung problems and different things like that. So that's how we think about respiratory as acute and chronic. So you've got to identify the contaminants and then answer the following questions. What is the contaminants concentration? How much of that contaminant is in the air? Are the contaminants vapors, gases, or particulates? It's very, very key. So like, for instance, right now, since we're in the pandemic, everybody wants N95 because the coronavirus is a particulate. Your vapor and gases, depending on some vapors and gas, depending on what state it is in or what chemical it is, depending on what state it is in. And there's a difference between vapors and gases. You think about like naphtha or gasoline, those are vapors. Gases would be things like ammonia, etc. So there is a technical difference. And then are those contaminants IDLH? IDLH means immediately dangerous to life and health. So if you have a common contaminant, you can literally go into Google, and if you had ammonia or chlorine, since you guys were wastewater, you got chlorine, you can type in chlorine NIOSH pocket guide, and it will literally tell you all this information. It'll tell you a lot of information that you don't need. Actually, I think I might have an example of it. Actually, I do have an example of it in this presentation. But it'll tell you all the information that you need to know if you have chlorine. I'll show you one. So determining if the workplace is IDLH. If you as an employer, say you had a manhole, Jason was like, hey Zach, we need to go in and do this work. If Jason cannot determine whether or not atmosphere, because maybe he doesn't have a gas monitor on him for whatever reason. If he can't determine if that's ideal H, you have to assume it's ideal H. So that's the problem. If Jason couldn't reasonably estimate the employer's exposure, you got to assume it. So that's why it's very, very important to know what potential you're exposing to yourself or other employees. So you got to consider if that's going to be ideal H. And every contaminant has a different, what they call ideal H. So of course you got dust, mist, and fumes. This is specific to particulates. There's a difference between dust, mist, and fumes. You know, fumes would be, a lot of people think it's a vapor or gas, but when you weld, that's actually a fume, which is considered a particulate because you're heating up the metal and that gets in the air, that smoke that you see, that's actually a fume, not a vapor or gas. Of course, paint sprays or pesticides would be in your mist. And of course, dust is pretty. One of the big things, I guess, when we're talking about chronic illnesses, which there's new standards around it, is your silica. Silica's in like concrete. So say you guys are putting in a new whatever, and you got to drill 500 holes of concrete. You know, you got to bore in holes. Of course, it's going to kick up dust like crazy. That's an issue. That's what we're talking about, making that respiratory selection. So maybe you're going in a confined space to do that. That's what that would be your respiratory. That would be your hazard. It may not be ideal H, but it's potentially hazardous to that employee where your gas monitor is not going to pick that up. So of course you got chemical and how a chemical cartridge works essentially, but you've got your vapor and gases. So you've got your gases is like hydrogen sulfide, chlorine, carbon dioxide. We make specific cartridges that filter hydrogen sulfide, H2S, and then of course vapors would be your solvents, gas, and naphtha. Yeah, that's how your filter works. You know, it just essentially has different layers of carbon in there, and it literally just passes through the filter, absorbs into that carbon, and doesn't go into the face piece. The problem is with filters like that is they can become full, and you don't know when they're full. And smell or taste can't be a reason that you change a filter. You have to change out before that, because if you can smell or taste it, that means you're being exposed to the hazard. So you got to change it out before that. So not to get too crazy technical, but you do have to have a cartridge change-out schedule within your respiratory. So for instance, if you're doing chlorine, you got it, and those filters don't last forever, so you have to have those filters on that change-out schedule. So a lot of people, what they do as a best practice, if you're like, hey, we're going to change, we've done our industrial hygiene studies, and we decided that your filter will only last every month. So you literally just write your date on the filter, and if you, of course, look and it's not October, or it's October now, and your filter has a September date on it, okay, and you throw them away and get new ones. And that's literally what people do for those cartridge change-out schedules. So making respiratory selection, where the big miss is with a lot of people, there's only two things you can use with what they call for ideal H applications. Those immediately dangerous to life and health. That's when you're below 19.5%. You can use a system like this, which is a pressure demand system with the escape bottle. You have to have this escape bottle on. This is what I'm talking about for escape bottle that's attached to it. Of course, you're breathing off that. That's if for whatever reason that runs out, your hose gets clipped, whatever. This is how you're getting out of that space. So you have to have this for an ideal H application. Or the other thing you can do is an SCBA. So you can't wear a PAPR, an air purifying respirator doesn't work, a continuous flow supplied air respirator, none of that stuff works. You gotta have, the only two things is an SCBA or a pressure demand with supplied air with escape. So how do you do it? You gotta determine the maximum use concentration. What is the maximum use concentration? You take the contaminant. So if we're going to stay with chlorine, we're going to take its permissible exposure limit, and we're going to multiply it by the assigned protection factor of the respirator. So I'm going to give you an example here that'll make this more sense. So you can see the formula. The PEL multiplied by the assigned protection factor equals that maximum use concentration. The thing is, what it says down here in red, you can't apply that to ideal H applications. And I'll give you three specific examples that it'll make more sense. So here's the respirators, this is specific to Honeywell. Here's what our different assigned protection factors are. So you can see things with, it obviously gets increasing the size. Your pressure to man with escape and SCBA is 1,000 and 10,000 times the permissible exposure limit, where if you have like an N95 mask or a half mask respirator, you're only getting 10 times the permissible exposure limit. So if you have a, again, going to give you an example of a permissible exposure limit here in a second on examples, but say your permissible exposure limit is 1, and you have a half mask respirator, you can only do up to 10 parts per million with that face piece. And if you're above 10, now you can't wear that face piece. Does that make sense to everybody? So how you would get it, here's how you would potentially find your permissible exposure limit on your STS sheet. So if you open up your STS sheet for that contaminant, if it's in that confined space, a lot of times in section 8 is what this is. It gives you your exposure controls, and you can see it gives respiratory protection specific for that chemical on your STS sheet. Now, unfortunately, sometimes on those STS sheets it says wear a respirator. You're probably like, no shit, wear a respirator. What kind of respirator do I need to wear? There's a bunch of them. So sometimes, like this is a great example, it tells you exactly what type of respirator you need to wear. So where my point is, I'm giving you resources to answer what seem like very hard questions are a lot of times readily available if you just know where to look. So look at section 8 on any SDS. And it also, of course, gives, other than respiratory protection, may give you other PPE is on there as well. But then, like, here's hydrogen chloride. Here's off the pocket guide. So this is what I was talking about for the NIOSH pocket guide. If you type in hydrogen chloride, and that every chemical has a CAS number, and you go to that link, at the very bottom, this is what it gives you. So it tells you exactly what you need to do based on the concentrations that are the different concentrations. Exactly specific what respirator you need to wear. So it's, I know it, like I say, it's a respiratory selection. It can be very confusing, very hard to do, but there is a lot of resources to make your decisions very easy. So here's your example, and I guess I'll only put one on here because it says example number 3. So if you have this XYZ chemical, doesn't matter what it is, if you've got a PEL that equals 5 milligrams per meters cubed, and you got an IDLH, say the IDLH is 2,000. So you're assuming I have an exposure level of 2,200 ppm, so it's above the IDLH. Can I use a continuous flow supply to air respirator that has an APF of 1,000? So what you do, you take the APF of 1,000 times it by the permissible exposure limit. So the problem is, though, and you can see here on the answer, is that you can't exceed that maximum use concentration. So there's only the two things, is the pressure demand system or the SCBA that you could use for that application, because it's an IDLH application. Because it shows over here, the IDLH was 2,000 and you're at 2,200, so you can't use a continuous flow because it's not allowed by OSHA. So here's what I was talking about specific for, if you're going to be doing that confined space entry. There's different versions of this. We have a version for high heat. We have just a nylon version. You can get a version with a harness integrated into it. But a lot of times I like to recommend this for confined space entry, because think about it. A lot of your manhole covers and if you had to go into a tank on the side, you're talking 24 inches. So if you got a tank on the back and a big guy like me trying to get my ass down, trying to climb down that ladder with an SCBA on my back, trying to climb down that ladder. It's a tight squeeze. Especially if I'm trying to rescue somebody out, now I'm trying to move around with this big old tank on my back. So this is why this system is a lot nicer, because it's a lot more low profile. I just literally have this, get this, let me just show you real quick. I mean, if you were looking to procure a system like this, somebody's getting my head on. That's what you're doing. So this is a much easier system. Now, the drawback is I'm tied to a hose. So yeah, I'm gonna have to drag this, pull this, it can get caught, etc. But it's much easier for me now to climb down that manhole cover with just this little tiny tank and a hose than with a big old SCBA on. Now I gotta bend down and try to pick somebody up, and if you ever worn an SCBA, the SCBA is digging in your back, and it's really hard, and the back plate's stiff. This is the difference. You're tied to the hose, you've got an air source. The other thing is, the drawback of the SCBA is, if you have an SCBA tank, you got a 60-minute, even a 60-minute tank, chances are you're not gonna get 60 minutes out of it because you're in a confined space. You're huffing and a puffing, so you're trying to pick somebody up, trying to rescue somebody, somebody is potentially unconscious, so you're amped up, you're breathing a lot harder, you might only get 30 to 40 minutes on that tank. What if a rescue takes longer than that? So now you gotta go up and send somebody else down. Whereas if you have a device like this and you have two, I only have one tank on here, but you can have two tanks, now I can continuously work where somebody upstairs is just swapping out my tank while I'm doing it. Now hopefully a rescue wouldn't take more than 2 hours. I mean, that's a long rescue. Now, potentially it could. Not saying it couldn't, but let's hope it, we're moving a little bit quicker than that. But that's the positive of this is now I can have a longer breathing of air, whereas a SCBA, I don't have that. Now, the problem is that if there was an emergency situation, this is a little bit longer to set up, where an SCBA is really one valve, I put it on, one valve I flip on, put my face piece on, pop it in and go. Whereas this, I gotta get both tanks on, I gotta hook up my hose, I gotta hook it up here, I gotta set the pressure right. So there's a little bit difference in emergency situations, the drawback from this to that. Now obviously if you're in a confined space application, this is already all gonna be set up with everything ready to go. But if you were thinking about buying one of these just for an emergency situation, maybe your fixed gas alarm goes off, you're like, oh crap, we need somebody to go in there and shut the valve off or fix the gasket or do whatever. This system is takes a little bit longer to set up, but now you can at least have the time to go in there to fix whatever the issue is. So there is this, like I say, it's a pressure demand supplied air system with an escape bottle. Of course, if you're going to use most any respirator that has a tight seal, so if you're going to use an N95, half mask, full face, all this, and you got facial hair, you can't have it. You got to be clean shaven. It's very, very important to keep that seal. We do have different types of accessories. Of course, you can see the air cart there, which is very popular for confined spaces. If you have plant air in your facility, you can buy a breather box, and that's what you can hook up for your air source with this system. You can hook up to one of those breather boxes that's just off your air compressor at your facility, and that gives you that great deep breathing air, the top left. You can't use an ambient air pump on the bottom left, and on the right you see it's a cascade system. So if you get the big bottles from like an air gas or somebody like that that's full of air, you can hook a bunch of those, like if you had like 4 or 5 of them, you could hook 4 or 5 of them together and have one air source where you're breathing off all those 5 tanks. So if you need to work for like 8 hours or something like that. So that's your different accessories. All of these, except the one on the bottom left, could be potentially used in a confined space respiratory application, especially if you're worried about IDLH applications. So we got a bunch of different types and styles of SCBAs. Really, you guys would just use one. It's our Cougar, or our Cougar series. It's just our industrial backpack. It's the version that's right there in the top right. Not the one with the hood, but the one with the face piece. I mean, you could use the one with the hood, but it's the same model. It's just a different face piece. But that's the one you would potentially use. If you're worried about things like where would I fill the tanks, there's people in Peoria here that can fill your tanks. If you buy a Honeywell SCBA, we have an authorized repair center in Washington. So it's really close. It's called SCBA's Inc. They do everybody around here, a lot of the fire departments and different things like that. So if you're worried about, hey, I need something fixed and need it quick, you literally have a 20-minute drive to your repair center. That's specific to Honeywell. You know, obviously every other manufacturer has their own repair centers. That's a Honeywell repair center over there. So you can do that as well. But there's a bunch of different types and styles. You can get it configured however you want, but really the version on the top right would be the one that you would potentially use. We're going to skip that one. We're going to skip that. Some of these I'm just going to skip because it's just a lot of detail. So here's what I wanted to get to was escape solutions. So Jason said they have these 5 or 10-minute escape bottles like this. So how this system works, I don't think I have any pictures of it. Now we do have, so there's 2 different types of escape. You've got what they call non-ideal H escape and ideal H escape. So we've got these things at the top that's a mouth bit. You really put it in your mouth. It's essentially an APR cartridge, and you got a thing that plugs your nose. It's only for acid gases and ammonia methylamine. There's the only 2 versions we make for that. Probably not something that you guys would potentially use. We also have the hoods there. You could potentially use those. Say you have an office inside of a plant where you got people working, and say what do you do if the chlorine alarm goes off or H2S alarm? How do you get out of there? So that's what that device is used for. It's only non-ideal H though, so it can't be ideal H application. So maybe they're not at the source, but they're going to have to walk by a potential area before it ventilates through. So that's what you can give them. The last thing, what I'm talking about here is a version on the bottom. This is used for escape applications. So maybe this is our room that we have a potential ideal H application. I can essentially wear this. I can hold it here on my side, and if something goes wrong, if my ring and run device goes, I throw this open. I got a hood. I know your parents tell you never put a bag over your head. You literally throw this bag over your head, you tighten it, and you turn on your air. Turn on your air. This device here is giving you 5 minutes of air. So it will give you 5 minutes of air. So if you're in this room and the alarm goes off and you're like, oh crap, or you're down in a manhole, you're way down underneath the city and you've got 100 feet to go out and your device goes off, this is what you're throwing over your head. Throwing this over your head, throwing it on, and now when I climb out of that space, now I got oxygen coming to me the whole time. $500. These things, again, can be serviced and repaired by SCBA's Inc. here in town. If you decided like, hey, that's a great idea, I think I want that for a particular application, I have a training deck that goes over it. These are very easy to use, very easy to maintain. The monthly inspections on these is literally checking this gas gauge to make sure it has gas in it, to make sure it has the oxygen in it. Again, it can be filled here locally. I think Getz fills a lot of, so they can come on site and fill them real quick for you. There's really not a lot of maintenance that goes with these. I mean, over 5 years, yeah, there's going to be some maintenance to it, but really there's not a lot of maintenance to this. But this can be a lifesaver. The other application where I see this having a place, what happens if you've got, in this situation, a guy going down, you've got your person up on the rescue. Say the person becomes overcome by gas and they can't put their own on. Now, you can either bring one of these down to them, or say you have, and maybe it's not even a confined space, maybe it's just a room. It's not actual pit or something, that's kind of what we always think about confined space. Maybe it's just room. Maybe it's got a little glass and it's your chlorine room or whatever. You do something in there. Say you can see a guy laying on the ground. I'm gonna go get an SCBA and bring one of these with me, so when I rescue him out, now I'm going to put this on his head and put it on his body, so when I'm dragging him out, now he's at least got fresh air, because if you take it in there, oh shit, the chlorine's gone off. Well, now he's just sitting there breathing chlorine the whole time, even as you rescue him. So that's how another application that this could potentially be used. It's literally a bag. It's a tea bag, so it's got the front has 2 sides, the back only has 1, so you know how to put it on. It's clear, so you can readily visualize and see people. And the training for it is, you bust out the hose, throw it over, you tighten it, and you turn on the air. And this doesn't have any air in it, so it's not working, but then you literally get 5 minutes of air or 10 minutes of air. So it just depends on how long your escape is, on whether or not you would buy a 5 or a 10-minute bottle. Yes, sir.
So with the 10-minute air escapes, so there is an annual flow test that you have to have performed by a licensed dealer.
It's a posi check. there's a posi check Honeywell makes a device, which is what SCBA Inc. has, that they do that annual flow test with.
And then also as a 5-year hydro test.
Mm-hmm. So you have to get these tests every 5 years, and that's, if you decided to buy one of these, I have like a 5-point PowerPoint slide that goes through all that information you just talked about. And it even has the training on how to use this. But essentially, yeah, it's got your yearly, and that's even if you bought one of these hip pack systems or an SCBA, essentially it's that same. You have to have a yearly flow test, and every 5 years you have to have it hydrostatically tested. That's the, and a lot of, there is some, it's specific to both SCBAs and these cylinders. There are some other things that potentially could be fixed, but of course that would all be, SCBAs Inc. could potentially manage that for you and replace anything as is. So great point, Jason. There is that maintenance piece to these devices. But really your monthly check is literally looking through this bag to make sure it actually has, it's in the green zone. It's got a little green valve there, making sure it's in the green zone. Everything else looks like it's there. A lot of people just, depending on the plant and the application, they have specific boxes that say emergency air. They're just a box. So you literally just go by in your monthly PMs, you pop it open, take a look at it, see if it's got air. If it's got air, you close it, and you're good to go. And you just, of course, got a tag on it, inspection tag, and you sign off on that inspection tag. So that's the, let's say, emergency air. If you decided you're like, hey, I don't think I want this, you can potentially go to those, and it's just a little less complex of a situation. So key takeaways, you know, the highly probable that a would-be rescuer could be potentially become a victim due to lack of training, experience, or equipment. You know, that could be from a fall protection standpoint, that could be a gas detection standpoint, or it could be a respiratory, or all of the above. You know, defining a confined space entry is critical. Again, a lot of people want to take a permit required confined space and call it just a confined space because they don't have all these different applications. You know, they don't want to have to do all the training, etc. Well, the one thing I will say, if you do have, you know, you have a big job coming up and you know it's going to be a permit required confined space and you don't have all this equipment, there are companies that do standby rescue. Literally, they're off-duty firefighters. There's probably some here in Peoria that literally what they do, they don't use this equipment. They have their own equipment. They bring on their own equipment. You tell them exactly what you're going to be doing, and they are sitting there the whole time as your attendant and your supervisor, etc., making sure if you have a problem, they're the ones that are going to go get you. So there are standby rescue. So if you know you have a project and you're like, hey, we only do it once a year, you can hire a standby rescue team that does everything for you from a rescue standpoint. So just as an FYI. And then be prepared with the right equipment and knowledge before work, and then using updated technology versus old products. You know, you talked about Rich, your harnesses and different things. You got a lot of outdated equipment. You know, even on SCBAs, you wouldn't think about it, but like if you've got old SCBAs, this is a second stage regulator. This is updated in the last 10 years to make it much more functional and easy to use. Where the old ones were big, they're bulky, you had to use 3 hands to do everything with. These are much nicer and much easier to use. That's the regulator that pops into the face piece like that. So you see how easy that was. The old versions were much harder to use. So, anyway. So, anybody have any questions or concerns? Do we have any questions on the chat? Sorry, I forgot to ask. No questions. Like I say, I appreciate your time. I don't know if I have my... If not, I'll have Jason, I think, on the very first screen.
I have it up.
Oh, you do?
Yep.
Okay.
You're talking about your email?
Yeah, just email, and if you got everything, if you want to put it up. So let me know if you have any questions. Like I say, I live in Bloomington. I do doing end user calls right now. Obviously, I'm here today. So if you got a specific application, if you just have questions, if you want me to come take a look at your fall protection equipment, if you need a gas detection specialist, if you want to just call them, if you want them to come on site and show you new monitors, we can do that. Of course, all this equipment here, I can bring it to your site and show you how to use it, how to work it, if you're interested in procuring any of it, or if you just really have a different application. Of course, we do head-to-toe safety, so if you have questions, I'll be more than happy to answer. Just give me a phone call or shoot me an email, and we can get you taken care of. But like I say, appreciate the time today. If nobody has any questions, we should be good to go. Thank you.